Good morning, students. So, in the last class, we discussed about the topic of an oscillation. So, now we have to discuss here that is the force law for simple harmonic motion. We already know the simple harmonic motion. It is nothing but the harmonic motion which have the sinic functions and the cosic functions. So, according to that, we have to take the force acting on the particle of mass m, the force acting on a particle of mass m in SHM. Let us consider by the definition of the Newton's second law, the force is equals to mass into acceleration. So what we discussed in the last derivation, we have taken A is equals to minus omega square y. We have already derived this derivation. So by using that, we can written as an y. Instead of y, we can write that x of t. So substitute the value of y in that A is equal to minus omega square y. What we get? A is equals to minus omega square x of t. Let's substitute here the acceleration A here. So minus you have to write and m omega square x of t. So m omega square we have considered as an k. So substitute m omega square as an k into x of t. Instead of x of t, we can written as an f of t is equals to k y. So we can write the same terms. Okay. Then next we can take as the omega square can be written as the k divided by m. And omega is equals to root of k by m. K is an torsional constant, what we called as a spring constant. M is the mass of a particle or a mass of a substance of a element. Okay. Then omega is equals depends on the root of k by m. Next, in that the Xerox notes, I will send that the notes that they have the question. So from the according to the omega is equals root of k by m, we can state that the force is directed towards the mean position. Hence we called as the restoring force. Hence we called as a restoring force. So next we have moved for this derivation. So has given the question is two identical spring constant k are attached to a block of mass m and fixed support. Show that when the mass is displaced from its equilibrium position, either side, if execute a simple harmonic motion, find the period of oscillation. So that the derivation is there. So further the derivation, then let us consider a diagram here. Then let us consider a block. So here the block, one end which fixed to the block and another is fixed to a rigid support with the force F1 and F2. It is nothing but the spring. When due to the two forces acting, then the net displacement we call taken as an x. So let me take for the individual forces acting on this object. Let me consider as an F1. It depends on the F is directly proportional to K. F is directly proportional to K. So X is directly proportional to X. That is displacement. Then the proportionality constant we can taken as a K. So according to that, what we can written as a F1 is equals to minus Kx. Similarly for the F2 is equals to minus Kx. Next, we have to find the resultant force or net force. So for that, we have to write here F is equals to F1 plus F2. We get F is equals to minus Ks, we get that F is equals to minus 2 Kx. So that we taken as an F is a resultant force or we called as a net force. By using this force, we have to find the time of oscillation of the body or an object. It directly we have the constant relation of this spring, that is T is equals to 2 pi root of m by 2k. T is equals to 2 pi root of m by 2k. M is a mass of the object or a mass of the block and k be the spring constant. So we have the direct relation along with the spring. We have to write that T is equals to 2 pi into root of m by 2k. It is a direct relation of the time period of oscillation. Okay. Then next we have to discuss about the total energy in the simple harmonic motion. So total energy means we have to consider here the movement we can take as a kinetic energy. The rest of the object we can take as a potential energy. So we have to combining of these two energies, we have get the total energy. So how you have to take here? So kinetic energy, we have the formula, the half mv square. So half mv square, that the half mv square, instead of the v, we have to take here omega square y square. So we have to take here omega square y square. So here v had written as ಏನಂತ ಬರ್ಕೊಂತೀನಿ